Hey A&Pers, this is Dr. Jones checking in. This is A&P 1 lecture test 4 video 15 covering page 16 of the Noteset. So we're talking about slow fibers versus fast fibers, and on the top of page 16 we start with a question: what determines the percentage of slow fibers to fast fibers? And that is your genetics determine that. Can the ratio of intermediate fibers to fast fibers be changed? Yes. How? Workout. Train the muscles. So in a chicken, I promised you would talk about a chicken. The white meat are the paler color, the fast fibers. So the white meat are the fast fibers. In chicken, that is the breast meat. Chickens don't fly much. They can fly, but not extended periods of time. They don't migrate like ducks. So in a chicken, the breast meat is white meat because they're only capable of flying up to roost. So if at night they want to be up off the ground. During the day, if they see a fox or predator or something, they will fly up into a short tree or something to get off the ground. And so the white meat are the fast fibers on a chicken because they're used for brief flight and not for very long. They have strength, but not endurance. Now, the darker color on a chicken, the dark meat, are the slow fibers, and the legs and thighs are the dark meat on a chicken because chickens walk around all day long, and they chase little lizards, and they catch snakes, and they eat little geckos. One time my daughter saw one of the chickens chase down and catch a tiny pinky field mouse, and she was devastated. She cried for an hour, my poor baby. It was a mouse. It was a field mouse in the yard, and the chicken caught it and like thwacked it around. And like, moral of the story, if you see free-range eggs and they say vegan, then they are lying their butts off because free-range chickens will eat everything. Got a freckle? They'll try to eat it. Hey, I'm recording. All right, so that was all about chickens and muscle fibers. That's how that works. So muscle hypertrophy, and I had to kind of stitch this guy together between two pictures, and it's not quite centered, so let's move out the way here. All right, so in muscle hypertrophy, this is the enlargement of stimulated muscle, so this is muscle building. And does bodybuilding add muscle cells? No. In muscle hypertrophy, you add mitochondria, you add energy reserves, so that was the myoglobin and the glycogen. You add myofibrils, which are these. You add myofilaments in each myofibril, so each myofibril gets bigger, okay? And you add myofilaments in each myofibril. So you're not adding muscle cells. In muscle hypertrophy, each muscle cell increases in diameter. So that's what muscle building is. You're not adding new cells, you're making each cell bigger. How does muscle hypertrophy affect the underlying bone? It strengthens it because bone is laid down along lines of stress. So when you have stronger muscles and you use them more, then you pull on them. When you contract the muscle, that pulls on the tendon, which pulls on the bone, and that strengthens the bone. So atrophy, which is our other term here, we've got hypertrophy and atrophy, the opposite. Atrophy is when the muscle fiber becomes smaller or weaker due to being unstimulated. So this is when you lose muscle size, tone, and power. And can generate a flaccid muscle, which is a weak muscle. Are dying muscle fibers replaced? No. So I think, there you go. This one clicks. I don't know why the other ones didn't click. What happens if you cut or damage a motor neuron? Because you can crush it, and that's as bad as cutting it. And this causes flaccid paralysis, where if the motor neuron can't tell the muscle cells to contract, then the muscle cells can't contract, because they only contract when the motor neuron tells them to. So, like polio attacks the motor neurons, which was why it was such a big deal. So, what was this picture? Oh, here's the motor neuron. The picture of the motor neuron. That's a good place for that. Is that all we got? And that's how you spell the word flaccid paralysis. Okay. All right, we weren't done with this though. All right, so physical conditioning. Aerobic endurance is 2 minutes or less, and this is without oxygen. And this is strength. So these are fast fibers. This is muscle building, muscle hypertrophy. This is limited by the amount of ATP stored, the amount of glycogen stored, and your lactic acid tolerance. When the muscles contract, they make lactic acid, which is a waste, and it's painful. And it is over time flushed out of the muscles, but when you're in the middle of it, there's not time. So, aerobic endurance, so that's anaerobic endurance, that's without oxygen, so that's short bursts, strength, not endurance. Aerobic endurance is longer, that is with oxygen, that is endurance. So stamina. Mitochondrial activities, so we burn oxygen and glucose to make ATP and carbon dioxide. And this does not make muscle hypertrophy. So aerobics are good for you, but they are not muscle building. Improvements in aerobic endurance result from 2 factors. Number 1, alteration in characteristics of the muscle fibers, turning fast fibers into intermediate fibers. And number 2, improvements in cardiovascular performance. Your heart gets stronger. You increase the blood flow, and you actually grow new capillaries to the muscles. So aerobic endurance, aerobics are important for heart health, but they do not build muscle. And strong muscles help you have strong bones. So you want both aerobic endurance and anaerobic endurance. What is cross-training? When you alternate aerobic and anaerobic training. So that's when you do both. And the benefits are you have the benefits of both. You have the increase in muscle mass, which causes an increase in bone mass. When you increase your aerobic endurance, which is increasing your heart health. So very important that you take care of your heart. This has been A&P 1 Lecture Test 4 Video 15, covering page 16 of the Noteset. Thank you, as always, for tuning in. It's good to virtually see you here. The education must go on. Dr. J out.